Similar to the last problem, we're going to be looking for variables, constraints, and an objective. Reading the problem comes up with the number of business class tickets sold and the number of tourist class tickets sold. Now the constraints come as follows. There must be at least 5 business class tickets sold. That leads us to the number of business tickets is greater than or equal to 5. At least 9 tourist class tickets must be sold. So T is greater than or equal to 9. And the plane does not hold more than 30 passengers. So business plus tickets has got to be less than or equal to 30. Now, what is our objective? Well, to make profit. $40 profit for a business class ticket, $45 in profit for a tourist class ticket, leading us to this equation. Now we'll need to graph them and find a feasible region. I've taken a random graph and turned it into one that should work. I've labeled business as the x-axis, tourist as the y-axis, and I've gone by 2s to get all the way to 30, because again, when business is 0, T has got to be 30, and when tourist is 0, B has got to be 30. The intercept method is often really helpful in graphing these linear programming graphs. The 3 graphs are labeled. B is greater than 5, T is greater than or equal to 9, and T plus B is less than or equal to 30. The shaded region is the feasible region satisfies all 3 inequalities. Now we're looking for our intercepts, or our intersections. Now that the feasible region has been graphed, the 3 intersections are important. These can be found either off of the graph or through substitution by plugging in 9 for T and getting 21, plugging 5 for B and getting 25. You'll plug in each point, 21, 9, 5, 25, and if you thought it was a possibility, 5, 9 into the profit equation, I can rule that one out. These 2 I couldn't tell by inspection, so I calculated them, and it turns out that 5 business and 25 tourist is the best option for the company to maximize their profit.